Hi, continuing on the last lecture. In this lecture, I'm gonna provide you another example to demonstrate how we can use one-pointer technique to solve an array question. So let's get started. Let's take a look at another example from LeetCode called gas station. This question I leave it as optional since it's a little bit challenge compared with previous two questions. If you feel it's too hard to solve it, just feel free to jump into the solution first, try to understand it, and come back later to try to solve it by yourself. Let's take a look at the description of this question. There are n gas stations along a circuit route, where the amount of gas at I station is gas I. And you have a car with an unlimited gas tank, and it costs I of gas to travel from the I station to its next I plus 1 station. You begin the journey with an empty tank at one of the gas stations. Given two integer arrays, gas and cost, return the starting gas station's index if you can travel around the circuit once in a clockwise direction. Otherwise, just return -1. If there exists a solution, it is guaranteed to be unique. Let's use example 1 to demonstrate the whole process. We have the input gas and cost arrays. The gas array is 1, 2, 3, 4, 5, and the cost array is 3, 4, 5, 1, 2. If we start at index 3 or station 3, and now we can fill up with 4 units of gas, and the current tank will be 0 plus 4, that is equal to 4. Then we can travel to station 4. The tank level will be 4 minus 1 plus 5, that is equal to 8. Then, since we reach the end of the gas array, to make a circuit around, we can start from the index 0 or station 0. And the current tank will be 8 minus 2 plus 1, that is equal to 7. And then we move to the station 1, the tank will be 7 minus 3 plus 2, that is equal to 6. And then, in the next move, we can travel to the station 2, and tank will be 6 minus 4 plus 3, that is equal to 5. And finally, we travel back to station 3, and the cost will be 5, so that our gas is just enough to travel back to station 3. And therefore, we can just return 3 as a starting index, since if there exists a solution, that will be the unique. Similarly, you can work through the example 2 by yourself. Here we provide several constraints for easy processing. Here, if you feel confident, I suggest you to try to solve this problem by yourself. Otherwise, if you feel it's too complicated, feel free just to jump into the solution first and then come back to solve it by yourself. Now, let's jump into the solution. The most straightforward solution will be the brute force solution. We can try to start at each index, and once we cannot travel back to the origin, that means it cannot be the candidate starting point. We can try each possible candidate starting point or starting index until we find the desired starting point. To do so, we need to create a nested loop. In the outer loop, we traverse each index of gas array to make that as a candidate starting point. And we can create a pointer called I to record the current starting position. And in the inner loop, we create another pointer called J to record the current position, and a variable called tank to record the current gas in our tank. For each possible starting point I, we're starting from it. That means the J starting from it, and update the current position J and the current gas level tank correspondingly. Once we find our tank is empty and J is not the same as position I, that means we cannot go back to the origin I if we start from the candidate position I. And otherwise, if we are able to back to origin I, that means we find the desired starting point. In this solution, since we created the nested loop, according to the multiplication principle, the total time complexity of the solution will be O(n) squared. And since we create three variables, I, j, and tank, the total space complexity will be O1. Here is the Java implementation of this solution. We create a class called gas station and a method called canCompleteCircuit. The input of this method will be two integer arrays, gas and cost, and the return of this method will be our starting index represented in integer format. As we previously mentioned, we create a pointer I and use a outer loop to traverse the gas array. So each possible I will be a candidate starting point. In the inner loop, we create another pointer called j that's starting from I, and tank initialize it as 0. At each position, we just examine whether we can travel around this in the circuit route. At each position, we update the tank as the previous tank level plus the gas j minus cost j. If we realize that tank is smaller than 0, that means we don't have gas to travel back to the origin, then we can just break. So this starting point, candidate starting point I, could not be our solution. Now we need to update the j. The reason why we use j+1 mod the gas.length is that if we reach the end of the gas, since we make it the circuit route, if we reach the end of the gas array, we need starting from the beginning of the gas array again. Now, if the j equals to I, that means we back to the origin, so that this starting point I could be our solution and we can just return it. Otherwise, if we traverse the whole gas array, cannot find any solution, any possible starting point, we can just simply return -1. Since this solution takes O(n) squared time complexity, it's not that efficient. And the more efficient way to solve this problem is by breaking down the problem into two subproblems. The first problem is that whether we can travel around the circuit once in the clockwise direction. If we can, the second problem will be, what is the starting gas station index? The first question is easy to solve, as we can see that if the total gas is smaller than total cost, we can make sure that we are unable to travel around the circuit once. But if the total gas is greater or equal to total cost, we can make sure that there must exist a starting index from where we are able to travel around the circuit once. So all we need to do to solve the first question or problem is to traverse the gas array to calculate the total gas and traverse the cost array to calculate the total cost and make a comparison. The time complexity of this step is O(n) and space complexity of this step is O1. The second question is a little bit challenging or trickier. To solve it, we can use a pointer I to traverse the gas and cost array at the same time. Use a variable called tank to record the gas we left, and use another variable called index to denote the starting index. As we move along the gas and cost array, the current gas we have will be the tank that equal to the tank plus gas I minus cost I. If here we notice that tank is smaller than 0, that means we cannot move forward. And it means that all the indexes before the current pointer I could not be the possible starting index, so that we can safely move the index forward to the I+1 currently. And after we finish traversing the gas and cost array, the index we get is the starting gas station's index. These steps take O(n) time complexity and O1 space complexity to complete. And in the final solution, we can actually combine the solution of problem 1 and solution of problem 2 together to just travel along the guess array or cost array once. The total time complexity to solve this problem will be O(n), and total space complexity to solve this problem will be O(1). And below is the Java implementation of this solution. Similarly, we create a class called getStation and a method within this class called canCompleteCircuit. And the input of this method is similarly the guess and cost array, and the output of this method will be the final starting point or starting index represented in integer format. As we mentioned previously, we create 3 variables, index, tank, as well as sum. Then we can traverse the guess and cost array once to solve this problem. At each step, we use the sum, update the sum to the current guess I minus the cost I, and tank to the current guess I minus cost I similarly. But if we realize that current tank is smaller than 0, that means all the previous index I could not be the possible or candidate starting index. Then we can simply update the index to the I plus 1 and reset the tank equals to 0. After we finish traversing the guess or cost array, if the sum is smaller than 0, that means corresponding to the subproblem 1, we cannot find any possible starting index. That means we can just simply return -1. Otherwise, our index will be our final candidate starting index. Let's walk through this code using the example 1. Initially, our index will be 0, and tank will be -2, and sum will be the -2. And then we update it. We update the index to we move forward to the 1, and update the index to 1, and update the tank to the -2 and sum to the -4. And then we move forward one step to the index I equals to 2, then the current index will be the 2. Since the tank is smaller than the 0. And then we update the tank to the -2 and sum to the -6. And then we move the I from 2 to 3, and since the tank is still smaller than 0, we update the index to the 3, and now the current tank will be 3, and current sum will be -3. And then we move I from 3 to 4. Since the tank is greater than 0, we don't need to update that, so we keep the same index as 3, and update current tank to 6, and current sum to 0. Since we find that sum is greater or equal to 0, that means we have this candidate solution, and we can just simply return index that is equal to 3 as our final answer. So, in summary, one-pointer technique usually uses one pointer to access elements and several variables to store intermediate states, which takes O(n) time complexity and O(1) space complexity. We used the 3 examples to demonstrate one-pointer technique. They find the largest element, majority element from the LeetCode, as well as getStation from LeetCode. In the next lecture, we are going to move on to another popular technique to solve array question, the two-pointer technique. Thanks for your attention. Stay tuned and looking forward to seeing you in the next lecture.